it's Miss Race, and we're going to be looking at the sine and cosine ratios today and how we can use those ratios to help us find missing sides in triangles. So if you remember from the last lesson, our tangent ratio is the change in y divided by change in x. Remember, a tangent ratio was our slope triangle. So if I look at this problem here, this first problem, it's asking if we can use the tangent ratio. Well, since we don't know the change in y and we don't know the change in x, we cannot use the tangent ratio. So I would say no, because the legs are unknown. Remember, another name for change in y, this would be an opposite leg, and this would be like an adjacent leg. And if we don't know either of those sides, we can't reuse that ratio, okay? So now we're going to look at, okay, well, what is a ratio that we might be able to use? Because with a triangle with 66 degrees, I know I can divide opposite over adjacent, but instead, maybe I want to compare two other sides, and I want to compare the opposite side with our hypotenuse. There we go. Or maybe I want to compare, for a cosine ratio, I want to compare the adjacent leg with our hypotenuse. Okay, so what we want to do is we want to verify in our calculator that the number you're getting out of this angle for the sine of 66 degrees, that you're getting this approximation. So I would open up the Desmos Scientific, just Google that, and let's type in sine 66. Now, if you are using a different calculator, you're using a phone, you're using something else, and you get this number out of it, you need to make sure your calculator is in the right mode. It needs to be in degree mode. The triangles that we're looking at, we are measuring them from their angle measures, which are degrees. So find that button that says DEG to try to change the mode of your calculator. And if you have a specific like graphing or scientific calculator, you might want to Google that calculator and say, how do I turn this into degrees? Or you can ask me or your teacher, okay? So we've got sine 66, we've got the right decimal, 0.914, and then let's do cosine 36. It's 36, and we've got 0.809. Let's make sure, and that's approximately the right answer. So one thing I'm going to put here is just kind of our abbreviation. I'd like for you to write this down. So our sine ratio, I'm going to abbreviate sine, just like we abbreviated tangent with TAN. I'm going to abbreviate sine with SIN. And that really represents the division of the opposite leg in a triangle and the hypotenuse in a triangle, okay? Our cosine ratio, I'm going to abbreviate COS, is the division of the adjacent leg with a hypotenuse in that triangle. So it's just what number would I get when dividing those two sides with each other, okay? So we're going to solve our problem in a very similar way that we did with tangent. So we have here, using a sine or cosine ratio, well, what I have in this first problem is from 66 degrees, well, these two sides are legs. Well, remember with tangent, we could not have used tangent for this. What we have is an opposite leg. Our adjacent leg is blank. We're not solving for it. We don't know it. So I'm going to leave it blank. And we have a hypotenuse, H for hypotenuse, O for opposite leg, O for opposite leg, H for hypotenuse, and then A is adjacent leg. Okay, so we'd say, okay, well, I want to do opposite over hypotenuse for this. And this ratio is similar to, it is our ratio for our sine. If you notice here, opposite over hypotenuse, we've got our 66 degrees, opposite over hypotenuse. What I get when I divide those two sides needs to equal this decimal value. Okay, so now we can say opposite over hypotenuse. I know that's a sine ratio, which is sine is, remember, opposite leg over hypotenuse. Then I can say, okay, well, it's a sine of 66 degrees this time, and the opposite is x, and the hypotenuse is 50. So from here, I would just do a cross product. So this would be x multiplied to 1 is 50, multiplied to sine 66. So x is approximately Now all I have to do is I'm multiplying this with 50. I'm going to put a 50 in front of it. So it's going to be 45.677. Okay, that's our approximate answer. We've got our exact answer and then an approximation of that. And then in our next triangle, these two sides are the legs. So again, we can't use tangent. So the sides that we are looking at is from 36 degrees. This x is next to it. It's adjacent. This 18 is a hypotenuse. So I'm going to divide it in this order here. It's similar to this triangle that we have here, which is also 36 degrees. And I know when I divide the two sides in this order, this is the number that it needs to be equivalent to. So I can say, okay, this is a cosine ratio, cosine of 36, or I'm just going to write out this one more time, is the adjacent leg over hypotenuse. So we'll say, okay, cosine 36 equals x over 18. Then we could do a cross product from there. X times 1, 18 multiplied to cosine of 36. And then we'll get our approximation. So now in my calculator, all I have to do is put an 18 in front of this cosine of 36. And that would be 14.562. I would recommend from here, maybe going to page 20, I think it's 24 next. That would be setting you up for problems that look very similar to this one. And when you're finished with that page 24, I would then come back. And then we're working on triangles that are kind of rotated around. This right here, you don't need to refill in. It is in your toolkit. I'm not going to fill it in with you. And then I'll set up and show you how we're going to work on question 5, and then I'll do a few of the other ones too. So on question 5, this triangle here, this side 50 is always a hypotenuse. I'm going to put an H next to it for hypotenuse. Okay, so we're going to use that in our sine ratio and our cosine ratio. But the 14 and the 48, those are going to change depending on what angle I'm looking at it from. So for example, from angle Q, for sine, sine is opposite over hypotenuse. So katoa, over hypotenuse. Opposite would be 14, hypotenuse would be 50. So 14 over 50. I would also go ahead and simplify that. What is 14 over 50 as a simplified fraction? And it is 7/25. Just divide by 2, essentially. Now the difference is from angle R, opposite is now 48. So that would be 48 over 50. And we'll go ahead and simplify that. And we'll turn that back in. So it's 24/25. Okay, now we kind of have all our triangle tools readily available to us. So we've got our SOHCAHTOA here, sine, opposite over hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. So what I like to do when I'm looking at a problem is I like to highlight my legs, and then I can say, okay, let's now identify the side I'm solving for and identify the side I know. So for example, this side I know is an adjacent leg. I know it's a leg. This side is a hypotenuse. So that means A and H, this is going to be a cosine ratio. So this would be cosine of 46 is equal to adjacent over hypotenuse. So for this one, I could just do x equals 28 multiplied to cosine 46. And we'll get our approximation here. So 28 cosine 46. That'd be 19.450. We'll try a couple more together. Maybe I'll try this one here. We've got from our 48 degrees, these are, well, first I like to identify my two legs. Okay, so this is the hypotenuse. Nothing's on that side. We're not using the hypotenuse then. So we're not using hypotenuse, so this can be tangent. This is opposite and adjacent. So we can say tan of 46 is equal to opposite over adjacent. You can do a cross product. X would multiply with 1, and then 17 multiplies with tan of 46. And then we would get an approximation for that, and I'll let you go ahead and type that into your calculator to get your approximation. And then I'll help you set up one more question. Let's do this one here. So let's do I've got my two legs. That means this has to be the hypotenuse. Our legs create the right angle here, or formed by the right angle. And so then from 29 degrees, this side is across, it's opposite. So I'd say, okay, opposite hypotenuse, this would be a sine ratio. So we'd say sine of 29 degrees is equal to opposite over hypotenuse. Now if we do a cross product, x is multiplied to sine 29, and that's going to equal 12, which would be multiplied to 1. So this one you're actually going to have to divide both sides by the sine of 29 to get x by itself. So you're going to get an approximation for that once you type in 12 divided by sine 29 in your calculator.